Hi, this is Math 1115, remote delivery. It was supposed to be for May 4th, 2020, but after singing happy birthday to my daughter and eating some ice cream and cake, I thought I would take a very short nap and do the work, and the clock moved on, and it was May 5 before I got to this. Sorry about that. Part 1 of 2. This is a content lecture on section 7.4 in your book, and it's graphing parabolas and applications. And please use this YouTube tool to perfect your understanding. I do like to open with a bit of encouragement, and there was a great football coach named Vince Lombardi who actually won the first two world championships, which now are called Super Bowls. And the quote that I want to reference is, "Winners never quit, and quitters never win." I encourage you, don't stop believing. If at all possible, do not quit. We can do this. Grades can be earned and rendered, and teaching and learning continues unabated. Keep in mind that the final exam is a mandatory requirement for completing the course successfully. Today we're studying section 6.4, the graph of the quadratic equation. It is also called a parabola. We'll talk about vertex, x, and even y-intercepts. And in your book they talk about solving this graphically, and those are not the kind of calculators we'll use, and so we'll do those problems differently. All right, so first of all, we're going to talk about y, and y is always equal to f of x in the form of ax squared plus bx plus c. You've seen this before. I think we call this the standard form. And so what we're going to do is we're going to just pick some points for x and see what y has to be and graph it. Here's example 1. So we're graphing y equals f of x, x squared plus 2x minus 3. We pick these values for x, we get these values for y, and we see we have something that looks a little bit like a U shape. This graph is called a parabola. And basically, anytime you have y equals ax squared plus bx plus c, we'll have the same basic shape. Now, it can open upward, and the reason we know this is opening upward is because the a, in this case, is 1. It is greater than 0. That means it's going to open upward. We are going to see that whenever the leading coefficient, the coefficient of the a squared, is negative, it will open downward. Also, this parabola has a minimum point. The minimum point is right there. This minimum point has a name. It is called a vertex. All parabolas have an extreme point of this type, and it is called a vertex. And it's going to be a minimum if the parabola is opening upward, and it's going to be a maximum if the parabola is opening downward. And so here is the one that we just graphed, but suppose we graph it this one that has a negative coefficient. This is the one we just graphed that has a minimum. The vertex is at 2 minus 2. We'll talk about how to find that point in a moment. And here, the other one, we're graphing this one where we have minus 2. It opens downward, and so the maximum happens at 2 comma 2. Those are both vertices. Now, here's a derivation of what is called the vertex formula, and it uses completing the square, which John and I decided we didn't make you learn. But this is derived and proven using completing the square. The important thing to remember is this formula. The vertex and y-intercept of a quadratic function that looks like y equals f of x equal ax squared plus bx plus c is, the vertex is, the x-coordinate is minus b, where b is this number up here, and b could be positive or negative. So this is minus b all over 2a. That's the x-coordinate. And for the y-coordinate, you take this x-coordinate and you plug it back into the equation, and you'll get f of, when you plug in, minus b over 2a. And so that's what we get. We also here say that the y-intercept, that's what you get when you put 0 in for x. Well, if we put 0 in for x up here, we're just going to get y is c. And moreover, and I'm adding this here, the axis of symmetry goes through the vertex. So in this case, it is x is equal to minus b over 2a. All right, so here we're supposed to graph this, find the vertex and the y-intercept. And so you have, this is our equation. And so the vertex, we're going to say, well, what is minus b over 2a? Well, it's minus, b was minus 8 here over 2, and a is 2. So I substitute those values in, do the calculation, and I get 2. So I'm going to take 2 and substitute it back in that equation. That will give me minus 2 when I substitute 2 back into the equation. And that says the vertex is 2 minus 2. And because a is greater than 0, it is a minimum. To find the y-intercept, we put 0 in here for x. When we put 0 in here for x, we get y is 6. So that point is 0, 6. The graph's going to look like this. There's the 0, 6. There's the vertex. This is the axis of symmetry going through the vertex, and that's the line called x is equal to 2. Let's look at an example using the vertex and intercepts. Now here we're talking about intercepts. That means it's both the x and y intercepts, and here's the equation. Now notice that this is a negative, so it is going to open down. So the vertex is going to be a maximum. So what we're going to do is we're going to calculate minus b over 2a. So here is minus, that's b over 2 times a, and you get 1/2 when you do that calculation. We're going to take the 1/2, substitute it in this equation. That's what we're doing here. And we'll get 25 over 4. So the maximum point is 1/2, comma, 25 over 4. That is the maximum point. The y-intercept is found by letting x equal 0. If x is equal to 0, I get 0, 0, and 6. So it's 0, 6. Now, we have to find the other intercepts, which are the x-intercepts. So what we're going to do is here y is equal to 0. So you see this is y is equal to all of this business, so I'm going to take y to be 0. I'm going to multiply both sides by minus 1, and it factors nicely. So I will get this factoring into x minus 3 times x plus 2. This will result in x being 3. Setting this equal to 0, the x is equal to minus 2. Those are the intercepts. I plot those points, and you see I can do a very nice graph. And I'm exploiting the fact that the axis of symmetry here is going to be x is equal to 1/2. Let's test what we know. So I'm going to ask you to pause the video. You know what to do and when to do it. But find the vertex, and is it a minimum or a maximum? Let's see. Well, if you put 0 in there for x, you get minus 4. So 0 minus 4. This leading coefficient is positive, so this is going to be a minimum. And when we do minus b, that's going to be minus 12 over 2a, which is 2 times a is going to be 6. So we will get minus 2. We take minus 2, plug it back into this formula, and we get minus 16. So there are your answers. Now here you have a parabola that is y equal x squared plus 1. Notice that b is equal to 0 here. That means that the vertex is going to be when x is equal to 0, because minus b over 2a will be 0. If I put 0 in here, I get 1. So 0, 1 is the vertex. I know it opens up, and so that's what I get. Notice that this never hits the x-axis. There are no x-intercepts. And the axis of symmetry is x equal to 0. There are word problems always, and we find that parabolas are useful in construction. So here is a picture of the Golden Gate Bridge, and that's a parabola. Now, one thing that you can do when you're solving word problems is you often can fix your coordinate system, pick your coordinate system. So we're picking the coordinate systems where this point right here, the vertex, the minimum point is at 0, 0. That means that the equation of this is of the form y equals, it is going to be a, and a is going to be a positive number, times x squared. And we also know that this point, which is when y is 300, x is 21 2100 or minus 2100. So we can take this point and plug it into this equation. So for x we'll take 2100, for y we will take 300, and we will solve and we figure out what a is. So this is the equation of the cable, and that means you can find any of these points that you care to. Now you can solve these problems graphically, and that's how your book talks about it in this section, but we don't need to do that, and John and I are not asking you to do that. So here we have s is equal to this equation, and but I want to talk conceptually. You see this is negative, so it is going to open downward. But that means you're throwing this thing into the air. It goes up, and then it comes down. Now you're interested in when it hits the ground often, and you're interested in how long it takes to get up here. Well, you see at any height, you can say, well, how long does it take to get height? So here it hits this height going up, and then it hits that same height going down. Sometimes there's two solutions, and here they're talking about the vertex. Now we're not solving this problem here because they're solving it with a graphing calculator, but we are going to a problem that is similar. This is problem 45. You know what to do and when to do it, so give it a go and let's see how you did. Let's see how you did. Okay, well, it is going to go up and it is going to go down. And so they want to know how long does the fuse last so that it explodes the top of its trajectory. So that means you'll find the vertex. So if you're finding the vertex, you're going to say it is minus b over 2a. Now both of those are going to be minus, and minus over minus is going to be a plus. And that number, if you change it to decimal, it's going to be just under 7 seconds. So that's where the vertex is. And if you want to know how high this firecracker is, you'll take this value of t and you'll substitute it back into this equation. If you do that, these are the coordinates of the vertex that you get. They didn't ask this, but they could have asked, oh, when does this shell return to the ground? And that would be found by solving this, where the height is now 0. Now if you put 0 is equal to all this business, like this, you have a quadratic formula, and you have to use a quadratic formula to solve it. If you solve it, you will get this number, and you will get this number. Now this number is negative, and time is not negative, so we will reject that answer. But you see, I can actually plot these values. Actually, this is the negative part. But you see, in about 14 seconds, the shell would return to the ground. Now, more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other.